Hey, welcome to our project. Today, I will be talking about succession on Point Pleasant Park following Hurricane Juan.
So I will be getting us started here. So a little background on Point Pleasant Park. It is a 75-acre park in Chibuktuk, Halifax, Chibuktuk, Nova Scotia. It was originally called Amnukati by the Mi'kmaq people, which means the place of spirits. This is really quite fitting because even now it continues to be a place of refuge and peace for many people who live in Halifax. So just some basic terminology that'll help for the rest of the presentation. We'll be looking at succession, which is how an ecological community changes over time after a disturbance. And we'll specifically be looking at secondary succession, which means the disturbance did not change the substrate. There's also climax community, which is the stable state in a community following a disturbance. Park is 40 or was 47% even-aged stands, which means all the trees were planted at the same time. And due to the density of the canopy, there were very few young saplings. It was also planted in shallow loam soil, which is prone to erosion. So when Hurricane Juan hit in 2003, 70% of the canopy was destroyed, which included 70,000 trees. So the park was replanted again as an Acadian forest. And we sought to examine how succession in Point Pleasant Park since the storm has gone. So we looked at 3 objectives. The first.
Moving on to the methods, the data collected for this study includes the tree density per species, the tree size in centimeters, the diameter at breast height for each tree per site. How was this done? Tape measurers were used to measure the tree at the diameter at breast height. This data was collected from the 6 sites in Point Pleasant Park, seen in the picture. And the data was collected annually, except for the years 2005, 2007, 2016, and 2020, due to hurricanes and in 2020, COVID. The most important question, why was a linear regression used? Linear regression is one of the best ways to connect variables to real-life situations.
So to look at the overall community and the tree density, our null hypothesis was that total density did not increase over time. We had an alpha where p was less than 0.05, and as you can see from the results, the p-value was significantly smaller. So we rejected the null hypothesis. Just a little background, though, before we get into the discussion, is that we originally looked at total tree density because it's an important indicator of regeneration and longevity and the ability of the trees that were planted in 2004 to actually take to the park. The state of the soil was not actually a concern following the hurricane because a lot of the trees had decomposed and were used as nutrients for the regrowth. And then finally, when we were looking at the data, we were looking for the climax community. And so this would be in a steady state. It wouldn't be a linearly growing relationship. So eventually we would expect tree density to even out as competition for space and light would set a carrying capacity. So we did see a positive relationship in the graph with, again, it was a significant increase. So we could say that there was a success in recovery as the trees did definitely spread and plant seeds. However, I would be a little hesitant to use this to predict because we can see that there are more variation in the data points later on. So it was a much stricter linear relationship earlier in the first couple of years, and then later on it gets a lot more variable. So the predictions from this would not be set in terms of forecasting direct numbers. Additionally, the R-squared value was 0.54, which is almost entirely in the middle, which means a lot of the variability was not predicted by a linear regression model. However, because of the variability towards the later years, this could be an indicator that the trees were not spreading as much and it was indeed reaching a stable state due to competition.
The second question in the results, they show that there is no significant difference between the red spruce and red maple dominant tree species in 2004 and 2023 in Point Pleasant Park, which means that the p-value is less than 0.05. And some things to look at there was there were very low R-squared values for both of them. And a lot of the trees had very slow recovery, although both of the slopes are positive. And dominance is permanently affected.
Alrighty, so moving on to question 3 of the results. This is the community metric section. I chose to focus on species richness because 70% of the species there were wiped out, so I thought it'd be great to see how all of them adapted and grew back. And how it will change as it reaches its climax. So this is a regression graph, and you can see that it does have a positive trend line increasing with the time. Right, so like I did discuss, there's a positive trend line with time. This is due to believed by research and conservational efforts done by local universities and local communities and just people helping. So the R-squared value is past the midpoint, 0.64, which is suggesting that it is soon to reach its climax and leave its succession period. Also looking back on to the regression line, you can tell with time increase, there's a lot more variance and selection, meaning that there's more different types of foliage moving in to propagate and grow on that section. But some predictions are that it would reach its climax before 2030, just because again it is past that midpoint. And the reason there's such variance is because from 2004 to 2023 at Point Pleasant, there were 6 different sites being surveyed, and they're in different areas that began with different foliage, and some other issues like conservation skewed it a little bit. That's just why there's a lot of variance. I predict that as the tree and shrub community continues to reach its climax, the species richness will slow and condense, but not stop, just because species richness can be used as like a buffer stabilizer to keep environments from reaching another succession period after such disasters like a hurricane. But moving on to the conclusion. So overall, the graphs and information we surveyed for this presentation showed that there was a positive trend line between the regrowth and the overall reproductive health of the environment with its increasing time. Obviously, since 2004 until 2003, there are a couple different reasons for that. One is genetic legacies. This is a little bit more on the genetical side, not ecological. Just saying that the variants may have skewed, and different seedlings might have a better chance of propagating into stronger foliage. But the more common one is coarse woody debris, aka CWD. CWD is really good for habitats. Again, it's good foliage. It's good for foliage. It could be food, it could be a resource. But the main attractions and reasons why it is so good for reforestation is its nutrient cycling properties and its ability to retain moisture. CWD can vary based off of volume, which has a direct effect on succession rates. Volume can be affected by many things, abiotic and biotic.